We'll now discuss how to integrate different powers of sine and cosine. We've talked about integrating some of these. In particular, if we have something like sine cubed cosine, we can use a u substitution. However, what if both sine and cosine are raised to a power? We can no longer do that u substitution. So there are going to be three strategies, and we'll look at them one by one and do an example of each of them. Our first strategy will be when the exponent of the sine x is an odd exponent. So things like sine cubed, sine to the fifth, sine to the seventh, etc. The first thing we'll do is we'll split off a sine x. So for instance, if we had a sine cubed, we'd rewrite it as sine squared sine. We basically just want to take one of those powers of sine and write it separately. The second step is to rewrite the remaining power of sine in terms of cosine. And we do this by using our Pythagorean identity. Sine squared plus cosine squared equal to 1. Finally, we'll do a u substitution where u is equal to cosine x. Here, we'll look at sine cubed, cosine cubed. So we do have that the power of sine is odd. The first step was to rewrite this and break off a sine. So I'm going to rewrite it as sine squared cosine cubed times sine x. We then use our Pythagorean identity and say that sine squared is the same thing as 1 minus cosine squared. And we still have this cosine cubed sine x. The final step was to let u be equal to cosine x, which means du is the derivative of cosine, negative sine x dx. Therefore, we have negative integral of 1 minus u squared, u cubed, and then the sine x dx is going to be du. I'm going to multiply this out. I get u cubed minus u to the fifth du. Once we integrate this, negative 1 over 4th u to the 4th plus 1 over 6 u to the 6th plus c. Therefore, my final answer, 1 over 6 cosine to the 6x minus 1 over 4 cosine to the 4th x plus c. And so I now have figured out this integral. Next, we'll use the fact that cosine x has an odd power and figure out the strategy for this. And this will be very similar to our last strategy that sine had an even power. We start this time by splitting off a cosine x. We rewrite the remaining power of cosine x in terms of sine x, once again using our Pythagorean identity. Finally, we'll do a u substitution where u is equal to sine x and be able to integrate. It's important to note that you could be in both the first and second strategy. For example, my last example, sine cubed, cosine cubed, I could have used using my sine strategy. I can also solve it using this strategy. If you do this, you will get answers that look very different. However, they are equivalent. So you do need to watch out for that. Here, my power of cosine is odd. We start by breaking off a cosine, so I'll write this as cosine squared sine to the negative 2 cosine. I then rewrite my remaining powers of cosine, which are 1 minus sine squared x, times sine to the negative 2x cosine x dx. This time, we let u be equal to sine x, So du is cosine x dx. This means I have the integral of 1 minus u squared times u to the negative 2 du. Rewriting gives me u to the negative 2 minus 1 du. I add 1 to the exponent and divide, and then the integral of 1 is u. Therefore, this is negative sine to the negative 1x minus sine x plus c. And we could also rewrite this as negative cosecant x minus sine x plus c. Our last strategy looks at what happens if both of the powers are even. Essentially, our strategy if both powers are even are to use our double angle identities, which are written here, to rewrite this. And then we'll use the preceding strategies to evaluate. So let's consider this. Our equation said that sine squared is 1/2 times 1 minus cosine 2x. Cosine squared is 1/2 times 1 plus cosine 2x dx. We can pull out the 1 over 4, and if we multiply these and FOIL out, we get 1 minus cosine squared 2x dx. We can then use this formula again to rewrite cosine squared. We get 1/2 1 plus cosine, and essentially this is called the double angle identity because we need to double the angle. This time it will be 4x dx. Integrating this would give us 1 over 4 x minus 1/2 x minus 1 over 16 sine 4x plus c. We can simplify this a little bit more and get 1 over 8x minus 1 over 64 sine 4x plus c. Well, that's a slight mistake. Shouldn't quite be 16. Essentially, we need to divide by 4, so this would actually be an 8, since we have a 1 over 4 and a 1 over 2, which would then make this 32. Much better. We will end by giving reduction formulas for sine and cosine. Essentially, if we're trying to integrate just a power of sine or just a power of cosine, we can use reduction formulas. The first one says the integral of sine to the nth power x dx is equal to negative sine n minus 1x cosine x over n plus n minus 1 over n times the integral of sine to the n minus 2x dx. So we can reduce this power of sine. In addition, we have one for cosine to the nth power of x dx, which is cosine n minus 1 x times sine x over n plus n minus 1 over n integral of cosine to the n minus 2x dx. So these are ways to reduce the power of cosine or sine that we need to integrate.